Hey, 6th grade, here's the second of 3 answer videos for the MCA sampler. This section has a calculator in the top right corner. That means you can use a calculator. I pulled mine up and now it's over here on the side, so I can use it while I'm working. Right, so here we go. Number 9, which statement is true? All right, so the very first thing I see is that this says 1/6. I know that's 1 divided by 6. So I'm going to put that in my calculator. 1 divided by 6. Ooh, that's 0.166666666. It looks similar to 0.16, but it's not the same. 0.166666666, right? Not the same. So it's not going to be A. Put a line through it. It's not A. B. Here's 4/5. So we'll do 4 divided by 5. 4 divided by 5. Oh, again, it looks similar. It's 0 and 8/10. You'll notice that this has an extra 0 here. So these do not equal each other. Cross it out. It's not B. The next one, C. 0.25, 0 and 25 is less than 1/4. So 1 divided by 4. 1 divided by 4. Hey, look, that's exactly the same. So this should say equals, but it doesn't say equals, right? So this is not true, and we'll cross it out, which means it has to be D, but let's do it anyway so we can talk about it. So here's 1/3. 1 divided by 3 equals 1 divided by 3 equals, whoa, 0 point all those 3's. So I'm going to write 0.333. It doesn't really matter how many I write, but what does matter is that I have the same number of decimal digits. If I write 3 decimal digits, there are 3 3's, then I need 3 decimal digits in the original decimal. There's only 1. So there's nothing behind that 3, so I have to put in the digit that means nothing. So that would be like 300. See how that works? So 333 is bigger than 300. I don't have to keep that many 3's. I could have just written it here as 33, which is 2 digits. So then I could make it be 30. In both cases, the fraction is larger. It's greater than. And you might remember, like this is a little mouth, right? So it's eating the bigger number. Some kids said that the arrow always points at the littler number, right? Whatever you need to do to remember, it is D. And if you put a star right in front of D, you'll be on your way to extra credit. Number 10, Kelly makes 12 candles in 3 hours. Lee makes 6 candles in 1 hour. What is the difference in the number of candles they make? They each make in 8 hours. This one is a complicated question. It's not necessarily difficult, right? But it is complicated. There's lots of ways to do this. First, we can talk about Kelly. Kelly makes 12 candles in 3 hours. Now that's comparing. So I'm going to write it as a rate, as a ratio, like a fraction. Right? We want to know how many she can make in 8 hours. But 3 is not a factor of 8. So I like to make it be a unit rate and change 3 hours into 1 hour. And if we do that, that's divide by 3. So on the top, it's divided by 3. So that means it's 3 candles in 1 hour. Right? But again, it said 8 hours. So I'm going to keep going. All right, equals 8 hours. So now that is times 8, and 3 times 8 is 24. She can make 24 candles in 8 hours. That's Kelly. Lee makes 6 candles in 1 hour. Lee makes 6 candles in 1 hour. Okay? But we want to know after 8 hours. So we'll make that be 8 hours. This one's not so tricky. That's times 8. 6 times 8 is 48. So Lee can make not 48 hours, can make 48 candles in 8 hours. And Kelly made 24. So the difference is that Lee made more. How many more? 48 minus 24 equals, and if you don't know that answer, 48 minus 24 is 24. So the difference is 24 candles. Lee is much faster at making candles. We don't know if they're better quality or not. Did you see my mistake? Looking over here at A, B, C, D. Oh my goodness, Miss Toivola getting a little bit distracted by the nice weather outside. 12 divided by 3 is not 3. 12 divided by 3 is 4. Right? And 4 times 8 is 32 candles. Right? All my work for Lee is correct. 32 candles. So now it's 48 minus 32. All right, 48 take away 32. That was a silly mistake. Is 16 candles. This is the real difference. When you do math fast, you might make mistakes like Mrs. Toivola. If you put a smiley face for Mrs. Toivola finding her own mistake, you put a smiley face next to it, you're still on your way to extra credit. Number 11, a bottle of soap costs $3.45 for 64 ounces. What is the cost per ounce? I notice that this says ounce and this says ounces, which means we want exactly 1. But we don't buy 1 ounce, we buy 64 ounces. So we'll write 64 ounces on the bottom, and we're going to change that into 1 ounce. And if you buy 64 ounces, you have to pay $3.45. So go from 64 ounces to 1 ounce, it's divide by 64. Divide by 64 on the top. Good thing I have a calculator. That would be a terrible problem, long division. $3.45 divided by 64. Yikes. Right? If this is money, then we'll say $0.05 because a 3 is less than 5, so we won't round up. Right? It's about 5 cents per ounce. A. And in front of A, I want you to write a triangle. Cool, that one was pretty quick. Number 12. A company is printing 250 calendars. In 1 hour, 75 calendars are printed. What percent of the calendars are printed in 1 hour? So we need to know how many calendars are getting printed. And that says 250. When they're done, they will have a whole group of 250 calendars. After an hour, though, they only have 75. 75 are printed. So we need to make that be a percent. When I do this, I like to do division and make it 75 divided by 250 equals. So we have 75 divided by 250 gets me 0.3, but I have to remember that if I want a percent, I really need 2 digits. So this is now 30. This is 30%, C. Need a hashtag next to C. All right, we're cooking. Number 13. We didn't talk about surface area at all. Right? This is pretty tricky. The surface area of a cube is 384 square inches. And if you know about cubes, it's a square on every side. So what you really need to know then, right, here's my front side. What you really need to know is how many sides are on the cube, right? So there's a top side, there's a front side, there's a right side, there's a bottom. There are 6 sides on a cube. Think about a dice, there are 6 sides. So we can find the area of the front side by saying 384 total inches split into 6 sides. 384 divided by 6 is 64. Now, that's saying that the area of this gold side is 64. And because it's a cube, we know that the side lengths are the same. That means it's 8 tall and it's 8 across, because 8 times 8 is 64. So now if you want the volume of the cube, now you would have to know, to find volume, you need to find the area and then multiply it by the depth. And this side is also 8. So this is really 8 to the third power, or 8 cubed. There it is, it's 512. This problem is so tricky. If you don't completely understand it, it's totally fine. We'll do some problems like this after the MCAs. Exclamation point for D. Right? To find the volume of a cube, volume equals length times width times depth. Right? Cool. Number 14. A heart shape is cut from a gridded piece of paper. What's the area of the heart? So first I'm going to say how far across that is. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 across. And then we're going to count down. Right, just a little bit more, but not much more than that. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so this is 10 by 9 pretty much. So it starts off as 90. So the area of all the red square, is 90. And then we have some spots here. And what I notice is if I take this part here, okay, and I move it over here and I kind of flip it around, right? If I could actually flip it over, it would make a rectangle, right? So this part here, if I could flip it over, would go perfectly right here. Okay, so that blue part, I'm going to take it away. And I'm going to say this one is 1, 2, 3, 4, 5, 6. It is 6. And it is 1, 2, 3, 4 and a half. 4 and a half. Right, so now we need 6 times 4 and a half. 6 times 4 and a half is 27. Right, so this part right here and this part right here are about 27, not exactly. Right, so blue stuff, or the blue area, is 27. So then we just have kind of these extra spots here. It's like 1, 2, 3, 4. Then maybe these little extra parts add up together for like another 1. And maybe 2 if you want to call it 2, because we also have this little spot right there. Right, so we'll say that the green area is, back 1, 2, 3, 4. We said about 6. So now I'm going to take the total, which was 90, and I'm going to subtract the 27 and the 6 that are combined. 27 plus 6. 27 plus 6 is 33. So this is 90. Take away 33. 90 minus 33. Whoa, that was times. 90 minus 33 is 57. So my estimate is about 57 square units. So looking at these options, right, the approximate area, I guess I would say 50. It's the closest. 50 square units. Okay, the next one. Jolene bought 12 apples. Each apple weighed 1.8 ounces. How many pounds of apples did Jolene buy? So the very first thing we have to do is say she has 12 apples, and each one is 1.8 ounces, so 12 times 1.8 gets us 21.6 ounces. Right? In total. That's all of the apples together. you need to know a conversion factor, which we haven't talked about because we still have 6 weeks left in this quarter after the MCAs. You need to know that 16 ounces is the same as 1 pound. So now if we're going to convert, we can put 21.6 on the top and figure out how many pounds goes on the bottom. Right, so let's do 21.6 divided by 16 gives me 1.35. So that means times 1.35. And I'll prove it. 1.35 times 16. Yep, gets us back. So times the bottom, 1 and 35 hundredths, gets you 1 and 35 hundredths pounds, because 1 times 1 and 35 hundredths. It's A. If you have $2 signs in front of A, when you turn this in, you'll get extra credit. Number 16. Eli has a cube with sides numbered 1 through 6 and a spinner with 3 equal sections labeled A, B, and C. He's going to roll the cube and the spinner. How many outcomes are possible? We did these types of problems. This is a 2-step problem. This is a perfect time to use a table. So we know he can get an A, a B, or a C. Right? There we go. And we also know that he has a cube, a dice, with the numbers 1 through 6. 1, 2, 3, 4, 5, 6. So what it's saying is, how many little squares are in this table? Well, it's 6 times 3, so it should be 18. 18 are possible, 18 outcomes. All right, outcome number 1 is rolling a 1 and spinning an A. Or he could roll a 1 and spin a B. Or he could roll a 1 and spin a C. Or he could roll a 2 and spin an A, or roll a 2 and spin a B. Right? So you can see there are 3 letters that go with each number, which is why it's 3 times 6 is 18. Last one in this video. 4 students each flipped a coin 50 times and recorded the results in the table. Who had a relative frequency of 3/5 of flipping tails? Something that's tricky in this problem is that the denominator isn't here in this table, but it is here. It says each one flipped 50 times, and we want tails. So one of these people has a relative frequency 3/5 flipping tails. So if we look at my Ka has 19 out of 50. Right? Heather has 35 out of 50. Jose has 29 out of 50. And Tyrone has 30 out of 50. At this point, ideally, you would know who it is just by looking at these fractions. But if you were stuck, then we can take 3/5 and make it be a decimal. 3 divided by 5 equals, Ms. Trebla knows this, but we'll put it in. 3 divided by 5 is 0 and 6/10. Now I'm just going to go through, move this over to the other side, and find out which one of these equals 3/10. 19 divided by 50, 0 and 38 hundredths. That doesn't match. 35 divided by 50, 0 and 76 hundredths. That certainly doesn't match. 29 divided by 50, 0 and 58 hundredths. 30 divided by 50. There it is. It's 0 and 6/10 right there. I knew immediately that it was going to be this bottom option, right? Because I can see the 3 and the 5 right there. So who was that? That was Tyrone. Right? This is our last one. So to get the extra credit on this assignment, you need dollars or hashtag smiley face. It's Tyrone. One more video coming to finish up the MCA practice assignment.